everyone. Not to meet you virtually. I'm Ming Wei. I work in the Windows data engineering group. I've been doing the data analytics for quite a long time, and I'm also helping out on City College curriculums. And if you need to ping me on LinkedIn, just please feel free. And I will start with my talk. So here's the outline. So first, I'm going to cover my use case, and then have a high-level description about the data schema. And from there, we're going to look at a few of the analytical queries. So using Citus4, and then I'm going to cover the storage and the data organization a bit, and then I'm going to conclude the talk, say why I used Citus, and starting from almost 4 years ago now. So first about the use case. So as I said, I'm working in the Windows data engineering division. We collecting Windows diagnostic data from an audience of 1.5 billion devices, and we're using those so diagnostic data to build dashboards, and it means this to gain the insights about the customer experience. So so every day there's hundreds of production dashboards. It's being refreshed say every few hours and being used by hundreds of the engineering team within Windows. So on top of that, so that each team also would do something I call ad hoc queries. So there'll be hundreds of users. They will initiate queries to the slice and dice to try to actually understand about the data and metric points and why some of the measures are failing. So I enclose a screenshot so from a public blog about our this internal product from Windows Data Engineering Division. So let's look at the data mesh a bit. So we have the Windows inside the Windows Data Engineering, we have a processing pipeline. So it stitching or sessionize the Windows diagnostic event and turn them into what we call the session-based measures. And then the pipeline is also using the Windows census data. You think about it as a reference data sets, stitching those on the Windows measure data to do something we call the dimension enrichment. So once the data gets loaded into the VanessDB, which is a Citus-based Postgres cluster, it's going through a few stages. In the first stage, so when the initially loading, it's getting into loading to a staging table. So from the staging table, so internally, so the database have a set of jobs. You can think about building up those materialized views. It's building a set of, say, reporting table for consumption. It means this is for efficient, say, query support. So besides the reporting table, we also are building, say, the stats table and the dimension table. These are very useful for customers to trust the data to kind of, sometimes they can do the self-serving, say, the data quality assessment. Now, actually, let's dive into the measure data schema a bit. So what is a measure? So measure is really a time series data about executing or exercising a specific scenarios. For example, Windows need to track on, say, the start menu launch latencies, or the Bluetooth, or the Wi-Fi network connectivities, and then also, of course, actually these days, say, the audio and video qualities. So each of those areas, we have sometimes hundreds of measures to track them. So a metadata from the, say, the database point of view, it has a dimension columns and also the metric column, right? So it has a few dimension columns like say the device ID. So each release of the SWAG Windows has put a unique device ID on each of the install. Right, so some of the has OS dimensions like build revisions and stuff like that, and some are say the device dimensions. So we have coming from census, we know say the make model about this particular device, and some of the dimensions are very unique to a measure, like I see the error code, or if you done some Windows program, it's called H result. So for the metric types. We have the bread and butter, have count, you have those as value like data types, and we also have say standard types like so in terms of metrics called key value types, say a string key, an integer count, or sometimes could be using say the double as a key itself. I mean, it's because we need to count many different things, and they're also I would say more complex, like say the metric columns, like say the histograms. So now we have a high-level view about what say the measure schema would look like. So let's look at the query part of this. For the query, I shared one query we call it device-centric aggregation. This is say the bread and butter query for my group. As you can see, we are doing the two-level aggregations. There's one inner query, we group by the device ID and a set of other dimensions, and then we calculate say the aggregates across say the device ID. So that as you can see that the device ID is quite essential in this calc, right? So the reason is kind of why we're choosing this part of this, because from the Windows data engineering experience, we found, I mean, doing this type of, we call it device-centric aggregation, or sometimes we call it one device, one vote, is help with, say the noisy devices, right? Because Windows have very large population, that if you do not, I mean, if not say one device, one vote, and sometimes say the faulty device would generating too much say noise, and this would say kind of dampen say the signal about the actual say the quality issues. So from this query, we can see immediately there's quite some technical challenges, right? Because of the device ID could be very high cardinality. This kind of this form of query is actually very expensive. So indeed, say 80 years ago, because this project has been going on for quite some time, and it's even before my time, we're using something we call cubing, effectively to pre-compute or to materialize the inner query. As we know, this type of pre-compute will be cursed by the dimensionality. It will going to use enormous amount of computing time and also using a lot of say the storage resources. So it's not economical, doesn't really scale. So for this talk, and I mean also kind of one reason we're using Citus is we choose to use, we call it dynamic compute. So also because this query, I thought it's going to drive the dashboard because with hundreds of dashboards, and then we have say over 1,000 monthly active user for this Advanced DB service. We need to handle about like 10 million queries per day, and 2 million of them are distinct. So we need to ask you some say device-centric query like this over and over again. And because Windows is a very big business myself, and we have say rich dimensions and also the metric types. So I think these are all adding to the technical say challenges, right? Because so supporting say rich type, especially extensible like data type, not a lot of the database system can do it. So now I can look at one query. It's actually doing the device-centric average query. This is one of the bread and butter query for us. We probably run this query of various shape, so over 1 million times a day. I know it's so quite a few things to read. I just highlight, okay, where to go by the device ID. This is a true device-centric query. And so the query result will be light up one section of the dashboard. But just from the query itself, you can look like this is just normal SQL, right? I mean, but of course, under the cover, so the Citus is actually doing its magic about query rewrites and executing this stuff on like many machines, and then aggregate, say, this results all back. But just from say the data engineering point of view, this is just a vanilla SQL query. So I think this is actually very cool. So here's another example to show how we do the percentile queries. As you can see, we calculate many like percentiles. So the query shape is also device centric, right? So on this device ID. So this is just to show that we're using an extended like data type, which is not normally in the say core, like say the Postgres, right? So it's called a T-digest to calculate the percentiles. And there is also say the magic under the cover. So it's built into the Citus how you do those say the percentile or the T-digest merge in a say like distributed MapReduce fashion. So now I'm going to show actually another query. So the scenario is like this. For certain things, like I say about some of the Wi-Fi failure because of the device, there are very so out of many millions, so hundreds of millions of devices, right? They only fail very occasionally. So the idea is we need to capture and calculate those at average failure rate. So in order to do that is it's quite simple query. I mean, just if we do want to say normally, right? So if you still do the inner query, like say the device ID, you calculate device average. However, if we do some mental math, right, and then we going to find out is to do an average calc, or so over let's say 200 million device over 28-day period of time, it would actually require over 200 gigabytes of data, right? So not only that, because this query need to be executed in interactive time, right? So say ideally for 5 seconds or less. So the idea is like if you cannot finish those kind of query at interactive time, then because I mean, just remember we have query volume is very big, and then the entire cluster will be so boggled down. For this type of query, I think right now, actually believe me, I can try this query with many different type of like, database system. None of them can finish so around like 5 seconds, right? And with the hope that say with Moore's law, I mean either Intel machines or ARM machines can come in the next few years. So basically, with current commodity hardware, is actually hopeless. So this is a place where we kind of need to use math to solve the problem. So it's kind of one of those in calc or the modeling tricks. So if we think about the problem again, right, because we want to calculate the failure rate, so then the calculation has two parts. One is I call this a numerator part to really calculate all the failure devices, right? And then there's say the denominator part, which is the entire population. So with a little bit of I would say the tweaking. So now you understand. Okay, what can we? Most of the time is actually calculating the whole device population. So quite often we can just using this device population itself as a proxy for the entire average, of course, say the whole like population. So by that, then we see, okay, they realize there is a very say unique and say like data structure called hyperlog log. So we can use that to calculate across hundreds of millions of devices. We can do the aggregate so very efficiently. So the trick is actually to use the hyperlog log to do the calculation for the denominator, and then just using normal average in calc, because it's only, well, I mean, at least for us, the failure is actually in the hundreds and thousands per day, and we can calculate this whole month at worth of so great, right? Because, and also keep in mind that because we need to do a multi-dimensional calculation, so that's why I say hyperlog log is actually very useful for this, say like a problem. So I think this is one of the neat tricks we found. And then right now we have hundreds of measures like that. So using the Windows like measure fleet, we're tracking many different kinds of the failures, and it has been very useful for us. I also include an actual query is one of those called say the ratio calculation query. If you want to so like stare at it, please feel free to do so. So now I'm going to cover say the storage or the data organization part of this talk. As you already know, Postgres has very rich data types, right? It has a key value store called HStore, and also supporting JSON very nicely. But then, so question is, at a large scale, how do you use so each of those, say, like data types? So for us, is based on my experience, is I'm using JSON or the JSONB really. So for the staging tables, as we talked about at the beginning of this data mesh, because JSON is very flexible, it can handle any of, quite complex like data types. So I model that easily. And then during the reporting table cooking time, we actually either flatten the JSON or we pick subset of JSON column, put it into those HStore types to serve as dynamic columns. From at least from our experience, I think the HStore type is actually smaller, and then which means less I/O to say fetch the data into the buffer pool. So this is just kind of an experience I would like to share. So the second thing is we're using partial covering index. I think it's somewhat mouthful, but I think this is one of the coolest feature in Postgres. For the reporting tables, because we are very high dimensional, we actually I'm creating about over 50 such indexes per table, right? So as you can see, yes, we're kind of overusing say the storage space a bit because to treat for the query time. So especially on a cloud machine, what it really does is turn called random I/O into the sequential I/O, right? So this is important in say the public cloud environment because I/O per second or the IOPS is actually very expensive to buy in the say the cloud environment like setting. So I think so the partial covering index to use it properly. This is kind of very important say the trick to actually managing those at a large scale like data warehouse. But sometimes you do need to be careful about how many you're going to create, right? Because the more cache index you create, the more writes it will have, and then potentially like sort of slow down your cooking time. So there is some art aspect about this. And also because it's like Postgres, right? So we can also add in our own kind of custom like data types. As I talked about earlier, for the metric, we have kind of key value types. We're actually using developed a custom HStore for the metric columns because we have a say the metric key, sometimes in string, sometimes in like double, but this value is always say count, right? Because we need to. So what it does is actually leveraging, say, the sum merge. We actually combining say the keys and also just sum the sums, if you will. To this we kind of use to handle say the histogram like data types. Okay, now I'm close to the end of the talk. Just to summarize, my journey with Citus, kind of why I chose to use Citus over like 4 years ago. When I started off, I realized that Citus has a great distributed SQL query execution engine, right? And from a few examples, as you can see, from the data engineer point of view, this is just normal SQL, right? So this is actually very powerful because Citus is actually seamlessly integrated into Postgres and give you like distributed query engine. So I mean this is a very say powerful thing, and I mean we actually love it. So the second thing is Citus actually over the past few years, they having a more as I call it extended data typing is actually very important for analytics engineering. So things like Hyperlog log and like T-digest, right? Because this is not only like a data type introducing at the Postgres level, and because we're doing the distributed query execution, then it actually needs to extend it into the distributed SQL query engine. So one side that has some built-in, so it's very easy to actually pick up and reduce the maintenance cost a lot, right? So, another thing is about actually scalability. So quite sometimes, like I say, okay, well, if the database actually scale, this is usually what most people ask, right? Can I throw more resources as is to kind of either lower the query execution latency or handle more data? So I have a few, say, the Citus clusters. So actually one of my cluster has about almost 2,000 cores, have say that 15 terabytes of the DRAMs and close to say 1 petabyte of say premium SSD. So those an Azure premium SSD. So it helped to grow our device-centric measure from say a few hundred. I mean, it was about 100 in 2018, and now it's at about 5,000, right? It's kind of show you this say the scalability of the system. And so lastly, it's, I would say Citus and along with Postgres, it's extremely reliable for data engineering. If you're operating things at a very large scale, if you need to ingest data 24 hours a day, and then you have queries coming. Sometimes it will be ad hoc queries. Sometimes it will be from say dashboard, or sometimes if they do the refresh any time, right? And so reliability cannot be say overstated, because it's very, very important, right? So I have one, say the Citus cluster along with an Azure VM has been run months, right? So uptime is measured in months. So I think this is actually essential, especially if you want to supporting so very important business. So Windows is one of such businesses. So actually for that, we are very happy. So with Citus and Postgres, and it's like a relatively ecosystem. So thank you very much for listening to my talk, and I'll be so actually happy to actually connect with you actually via other forums, and including just ping me on LinkedIn.